Welcome back to Mr Gard's maths class. In this lesson, we're going to be looking at measures of spread. You might have noticed if you watched my last video that I've got the same set of data drawn up on the page in black. Now, the first little bit that we're going to look at is the range. The range means the difference between the lowest and the highest score. So quite often when we are looking at measures of spread, it is normally always easiest to put the numbers in order first. So I've already done that with these numbers. Now these numbers could be test scores or cricket scores or what have you. It doesn't really matter. The range for this though is the difference between the lowest and the highest score. So you can determine that by getting the highest number, taking away the lowest. In this case, the highest number is 20, the lowest is 1, therefore the range is 19. So the gap from the smallest to the highest is 19. The interquartile range is what is probably going to be new information to you. So the interquartile range is known as the middle 50% of a data set. So if we think about the wording here, inter means inside, quartile, if you think of the word quart, it means 4. So we are dividing a set of data into 4 groups, and then we are finding the middle 50%. So 4 groups, each group is 25% of the data. We're finding the middle 50%. What that allows us to do, if you can think about it, is that we can remove outliers, so numbers that seem a little bit off. I highly recommend that you write these 1, 2, 3 dot points down in your book, because these will be really important go-tos for how to solve a question like this. So sort the numbers into order. I've already done that. 2, split the data into 2 halves. Ignore the middle score if there is one. So you need to find the middle of your data set. I have 11 numbers here. So my middle number, I think, is this. I can check. I've got 1, 2, 3, 4, 5 numbers to the right, 5 numbers to the left. So as the instructions say, you split it into 2 halves, but ignore the middle score if there is one. So I'm going to ignore that middle 3. Now I've got 5 numbers on either side. Your next step is to split the lower half and the upper half into halves. So I've got 5 numbers here, so I've got to split it there and split it there. So the way we can sometimes draw this is a bit like, I'm going to put a little line at each of those marks. You can draw something like this, where that is a 6, that is a 2, the middle was a 3, the highest is 20, the lowest is 1. What I've done now is I've divided that full set of data up into equal groups pretty much. So 6 is the middle score of the top half, 2 is the middle score of the bottom half. So what this has now told me is my interquartile range, the IQR, is equal to 6 take away 2. So interquartile range, remember the range is the smallest to the largest, or the difference. In this case, it is 4. So the middle 50% of the data has a gap of 4 from 2 up to 6. This sometimes can allow or removes the effect that an outlier would have. If this was 2000 instead of 20 on the end, the interquartile range would still be 4. Let's have a look at another set of data. Same numbers, except in this case, I've added in a number, 100, a bit like in that last lesson. So same deal, sort the numbers into order. Okay, that's done. Number 2, split the data into 2 halves. Ignore the middle number. Now, I believe that is the half mark. I'll just double check. 6 numbers on the left, 6 numbers on the right. Because I added a number, we have an even number. So there is no middle number per se. Our next job is to split the lower half and the upper half into halves. So again, that's going to split that bottom half. That's going to split that top half. Now, that therefore is my interquartile range from 2 up to 6. So the interquartile range is exactly the same as before, is 4 again. That's because even though we added a really high score onto this set of data, it didn't actually change our middle 50%. An example where the interquartile range might be important is sometimes it can be used by scientists in, monitoring temperature change in global warming, for instance. You look at the, years and years worth of data, and occasionally you'll have a cold year or occasionally you'll have an extremely hot year, but what they want to monitor is that middle section. Is that middle interquartile range slowly moving up or slowly moving down? Rather than looking at the individual temperature of the year, you look at it over a long period of time and work out, is it slowly going up? So is this interquartile range slowly changing, whether it's going up, down, or staying the same? This was just another lesson on how to look at and use different sets of data. Thanks for listening. Good luck on doing some of your questions.